Let us solve one or two problems of VTU Model QP for 2021. The first problem is find the support reactions for the beam shown in the figure. So this is the beam given. Here you can see that one support is hinge, another support is a roller. A is a hinge, B is a roller, and BC is the overhanging portion. So it is a simply supported beam with one side overhang. It carries a UDL of 30 Newton per meter for a length of 2 meters, maybe from A to C, and a triangular load of which varies from 0 to 50 Newton per meter over a length of 2 meters, that is in the region DB, and a concentrated load of 40 Newton at C. Distances are given as 2 meters, 2 meters, and 2 meters. Now we have to find out the support reactions. So A and B are the supports. Normally in general at the hinge support you will be having two reactions, one in the x direction, another one in the y direction, and roller we have only one reaction perpendicular to the plane of the roller. But here, since there is no inclined load or horizontal load acting on the beam, you have only one reaction at the hinge also. That reaction is vertical reaction because the loads are vertical. So vertical reaction will develop at A and result as this RA. And one vertical reaction at B on. So we have to find out now the values of RA and RB, reactions at A and B. So for that we need to use the equilibrium equations. So here since only two unknown reactions are there, we can use only two equations of equilibrium, sigma Fy 0 and sigma Ma 0 or sigma Mb 0. So these two equilibrium equations we can use. Sigma Fx is equal to 0 is not required here because there is no inclined load and there is no horizontal reaction. Now before using these equilibrium equations, let us transform these loads into equivalent point loads. So in that case, it will be like this. The free body diagram of the beam, after converting to equivalent point loads, so this UDL can be converted to concentrated load. The load will be 30 into 2, 60, which acts at the midpoint. So here I can write like this: 60 Newton acting at the midpoint means it is 1 meter. 1 meter from B. Okay? Yes, this is where it acts. That's the point I can get it as B. Then I will convert this triangle load to equivalent concentrated load. Total load will be area of the triangle. So area of the triangle will be half into 2 into 50. So it will be 50 only. So 50 Newton. This is the equivalent concentrated load, but it acts at the center of gravity of this triangular load, which will be at 2/3 from this test, 2/3 of this 2 meters. So I can take that load as acting at 50 Newton is acting. So now this is B. So 50 Newton will be acting at a distance of 2/3 of 2 meters. 2/3 of 2 meters becomes 1.33 meters. 1.33 meters from B. So this distance, now from here to here is 1 meter. From here to here it becomes 1.33 meters. Then we have the reaction at B. So here we have reaction at A. Reaction at B will be here. This is B, or B will be there here. This distance will be, you can see that this distance will be 1/3 of 2 meters, that is 0.67. So this distance will be 0.67 meters. And of course, at C he has given a load of 40 newtons. So this distance is 2 meters. So this is the free body diagram of the beam. Now then what I have done is I have converted the triangle load and UDL to equivalent concentrated load acting at respective points. Now we have to apply the equilibrium equation for this free body diagram of the beam. So I will use the first equation, sigma Ma is equal to 0, first equation. So algebraic sum of the moments of all the forces and reactions taken about the point A equal to 0, and sign convention I am going to use clockwise moment positive, anti-clockwise negative. Now I am here, so I have to write the moments of all these 1, 2, 3, 4. All these 4 60 Newton is giving a clockwise movement about A. So 60 into 1 meter. This is for plus because it is giving clockwise movement. Then this 50 is also giving a clockwise movement. So plus 50 into this distance is 2 plus 1.33, 3.33. This RB is giving anti-clockwise movement. So minus RB into distance here it becomes 4 meters. Distance from A to B is 4 meters. Then this is giving clockwise movement, so plus 40 into 6 meters. So this is the equation, moment equation, which will be equal to 0. Now if you simplify this, you can get the value of RB, reaction at B. I think you are going to get 116.625. So by simplification, you get RB as 116.625 newtons. Since you got the value positive, the zero direction of reaction at B, RB is upwards. It is correct. So this is how we can find out RB. Now the second equilibrium equation, I am going to use sigma Fy0. Forces acting upwards, positive, downward movement. So let us apply for the same diagram. This RA and RB, they are positive. You can see RA plus RB. Whereas the other forces are negative. Minus 60, minus 50. Minus 40 is equal to 0. So from this we can get RA plus RB is equal to 150, or I can write RA as 150 minus RB. RB is 116.625. So if you simplify that, you will be getting RA value as 60 plus 50 plus 40, it becomes totally okay. 90 plus 150. 150 minus 116.625, which is I think 33.375 newtons. This is the answer. This is also upwards. So because the positive value or assumed direction of reaction is correct. So this is how we can find out the reactions. So only here two equations we are using because there are only two unknowns. So this is one problem. The second problem in the same question paper is with respect to kinematics problem. The problem is given like this: a particle of mass 100 Newton. Second problem: a particle of mass 100 Newton is acted upon by a force. Is acted upon by a force. F is equal to, he has given like this, 20 t square minus 40 Newton, where t is the time in seconds. T is the time in seconds. Okay. At t is equal to 0, at t is equal to 0 seconds, velocity of particle is 5 meters per second, and also x is equal to 0. X means that the displacement is equal to 0. Find velocity and position of the particle at t is equal to 2 seconds. Find velocity and position of particle at t is equal to 2 seconds. So this is the problem given in the model paper. So you can see here, well, let us understand the problem. The solution looks like this. In this problem, we have given the relation between force and time. So the given relation, force is equal to F1, that is 20 t square minus 40. This is the relation F1. He has given relation between force and time. But according to Newton's second law, we know that F is equal to mass into acceleration. According to Newton's second law of motion, F is equal to mass into acceleration. So here mass of the particle he has given 100 Newton. So actually 100 Newton is nothing here. So mass I can take it as weight divided by g. That is 100 divided by 9.81. So which is I think you are going to get m as 10.19 kgs. Please note that when weight is in newtons, mass will be in kgs, SI units. So therefore, F is equal to m into a means it is 10.19, that is m into a. So this is what we can get. But also he has given the relationship between F and T. So therefore, what we can do here is, so we can equate these two now. So that 20t square minus 40 can be equated to this 10.19a. So we have 20t square minus 40 is equal to 10.19 times 6. So from this you can calculate a actually. So what he has at t is equal to 0, let us calculate the value of a. So at t is equal to 0 means initial when that means the particle is moving like this. T is equal to 0 is here. This is the initial. When time t is equal to 0, initial velocity we can take and the acceleration also we can find out. So already the body is moving now. At t is equal to 0, so what happens? This term becomes 0. Minus 40 is equal to 10.19a, or a is equal to minus 40 divided by 10.19. It is minus 3.925. Minus 3.925 meter per second square. Minute of acceleration. Since you got the negative value here, this is the equal retardation. That means already the body is moving and it is coming to rest now. So brakes are applied like that. Okay, that particle will come to rest after some time. So when t is equal to 0, you have this acceleration minus 3.925 meter per second square. Now let us check. He has given some conditions there. At t is equal to 0 second, x is equal to 0. X means the displacement. X is the displacement. Now what I can do now here is let me check that equation now, equation of motion. Let us check it. So we have that s is equal to ut plus half at square. That equation we have got. That is the one of the equations of motion. S is equal to, I will continue here, ut plus half at square. Now what happens? At t is equal to 0, you can observe that s is also 0. That means s is here x. X is s here. So therefore, at t is equal to 0, s is equal to 0, it is already automatically satisfied. It is satisfied. So one equation of motion is satisfied now. Now coming to the second equation. Second equation of motion is v is equal to u plus at. This is the second equation. Now if you use this equation, so you can find out the value of v by knowing the value of u. So here, since he has given at t is equal to 0, velocity he has given 5 meter per second. He has given. So at t is equal to 0, velocity. So we take that velocity as u because initial velocity it is 5 meter per second. So the value of u is known. Knowing the value of u, you can find out v now. V is equal to 5. A is minus 3.925 times t. Like that we are going to get. This is general equation. Now in this equation, if you put t is equal to 2, if t is equal to 2, that means when during the motion, when the time is 2 seconds, velocity we can get. So v is equal to 5 minus 3.925 into 2. So if you simplify this, you are going to get negative value, that is minus 2.85 meter per second. Minus 2.85 meter per second. So what is the meaning of this negative velocity? This is important here. So the particle is moving like this. When t is equal to 0, a value is minus 3.925 meter per second square. when t is equal to 2, it starts moving backwards. That means velocity will be in the opposite direction. So this v is 2.8. The negative sign indicates that it is traveling in the opposite direction. That is the meaning. Okay. So numerical value is important for us. Now he has asked velocity and position. So at t is equal to 2 seconds. So this is the velocity at t is equal to 2 seconds. So one answer we got. Negative sign indicates that it is traveling in the opposite direction. Next, the other one, he has asked what is the distance traveled. Distance, position is distance traveled, that is x value. So you have this another equation, v square is equal to u square plus 2as. So here please note that s is equal to x here. So at t is equal to 2 seconds, what is the distance traveled? So this is your distance traveled. Okay, yes, or x. This you can find out using this formula. V you have got now minus 2.85 square. U we have got u can 5 square. My a is negative here. Minus 2 times a is 3.925 into x. X is the unknown. Yes, or x is the unknown. If you simplify this, x you are going to get 2.15 meter. 2.15 meter. That means distance traveled by the particle is 2.15 meter at t is equal to 2 seconds. So this is how we have to do the problem. So he has given relationship between force and time here. So by using Newton's second law of motion, we can equate that given force to velocity to acceleration. Then we can find out the acceleration part. Then we can find out the velocity part and the distance traveled. So this is how we have to solve it.